In order to solve questions relating to clutches and clutch discs, we have to understand how a clutch disc works. Clutches are comprised of wound clutch discs and friction surfaces. The disc has a sacrificial friction material on it. In some cases, it's things like carbon or carbon ceramics oftentimes. And these are meant to wear away over time. And this friction material allows the clutch to be modulated in order to control the engagement of torque or power. And here in this diagram, these would represent our sacrificial friction materials, or our clutch discs, which you have to repair as they wear out. All right, next, let's look at a question that we'll commonly see in this course and that we might have to solve. So in this question, it says a multi-disc clutch is to operate in oil and be able to transmit a design overload torque of 800 Newton meters. The discs are alternately high carbon steel and molded asbestos with inside and outside diameters of 90 millimeters and 150 millimeters. Our Pmax is 1,000 kilopascals and our friction is 0.1. How many numbers of discs are required? So here's our givens. We obviously have torque, 800 Newton meters. We have our radius, initial and final, and our Pmax and friction. So we need some assumptions first. Let's assume that the friction is constant. Let's also assume that the friction force on bearings is negligible. And lastly, let's assume that pressure distribution is uniform. Okay, great. So now we can get on to solving this question. So some analysis. Simply, if you remember from the slides that we did, we know that we have this formula where torque is equal to pi times Pmax times initial radius times friction times final radius squared minus initial radius squared times newtons. Times number of discs. So 800 Newton meters is our torque, which is equal to pi times, our Pmax is 1,000 kilopascals or 10 to the 6 newtons per meter squared. We need to convert to meters, so 0.045 meters times 0.1, which is our friction. And here we have our final in meters, our final minus our initial in meters squared times number of discs. Therefore, solving this question, we know that the number of discs is equal to 15.76 discs. So that's how many we need. But of course, you can't have 15.76 discs. So what we're going to do is we're going to round up because you can't have less than that or else you'll experience failure. Therefore, round up, and our number of discs is equal to 16. Thank you for joining me. See you next time.